welcome you guys to our bootcamp, purposely on Starknet. And for those of us who were in the first session, we talked about a general introduction to blockchain. And just to have a recap of blockchain, so blockchain, basically these are interconnected nodes. You may think of a node as a computer. So maybe just to give you a few minutes of a recap, I want us to think of blockchain as this, in that the current internet we use is that if at all I have an application like WhatsApp, how it works is that, for example, if I've written a message, that's a post request. In case you are familiar somehow with programming, if I write a message, I send it somewhere, and probably it goes to the database. Probably it goes somewhere. It goes to the database, and the database queries the person I'm supposed to send to, and that's the person who receives that message. And then if at all I'm to receive a message, it's picked from the database and is brought back to me. But we have had cases whereby internet is down, and you cannot access your data. So that's the problem with the centralized system. But with a decentralized system, and that's the blockchain. We talked about the characteristics of a blockchain. The blockchain is decentralized. So in decentralized, this is what it happens. So you have interconnected computers. Just imagine I have a computer here, and then another person in America has a computer, which is a node, and then these nodes are connected. So in case something happens in one node, in case something happens in one node, and maybe one node goes down, the other nodes can be able, before that, when everything that happens in one node is shared in other nodes. I want us to best understand nodes as computers. So in case one thing happens in one node, the signature of that activity is shared in the other nodes. Now, in case this node is not down, another node can be able to take on the responsibility of the other activity in the other nodes. So you can never have a situation where the blockchain is completely down. It can never happen. So what does that mean? That means we have a lot of power. There are a lot of things to leverage that. Does anyone have a question around that? I want to really explain everything bit by bit. In case you have any question, you can just write it in the chat, or you can just unmute and then you raise it. So that's how blockchains work. And the blockchain, the very base layer we know is Ethereum. So even in the blockchain, we have a centralized system. Now we have a centralized layer, and Ethereum has been built to be that secure layer in the blockchain. And by that, very many chains have built on top of Ethereum to utilize the power of Ethereum. And one of those chains, okay, I love your question, Keith. Blockchain and Bitcoin, what came first or what came first? So it was Bitcoin is what came first. I believe that you want to know what came first. So it's Bitcoin that came first. So Bitcoin basically came to replace the traditional way of handling, of buying and selling. And then there is that day, I think it's in the month of either March or May, where we celebrate the Global Pizza Day, where someone, it was where the Bitcoin was able to be used as a medium of exchange. So that's the first day where someone had his sats. Sats is the denomination of currency for the Bitcoin. So Bitcoin came first, but Bitcoin had limitations because it was limited on only finances, money, yeah. And yet the blockchain, so the Bitcoin, I want us to understand that Bitcoin is just uses the blockchain technology. So Bitcoin was limited, so it could not handle various application use cases, yeah. And that's what makes sense in the world. I'm supposed to have a system whereby I have a lot of power. I can be able to use it in various things, yeah. So those were the limitations of the Bitcoin, yeah. So Bitcoin is mostly limited to money, yeah. It's mostly limited to money, yeah. So hope I've answered your question properly, Keith. Yeah. Thank you so much. So because the Bitcoin, the infrastructure was so limited, other innovation had to come in which can utilize the full power, yeah, of the blockchain. And that's how innovations like Ethereum came in, yeah. Ethereum handles a lot of things. It has very many use cases. It has use cases in DeFi. DeFi means decentralized finance. It has use cases in insurance. Just imagine a case scenario, yeah. So let me just give a use case of the blockchain, yeah. For example, I have a record today, and maybe I'm going to give a project which I happen to be working upon. I have maybe a record today, and maybe I've written, I don't want any other person to check out this record. I only want Keith to be the person to unlock this record, yeah. So I must give Keith something, yeah, so when Keith receives this message, yeah, I must get a cryptographic proof that it's only Keith who has received this message, yeah, that no any other person has seen the message that I want to give him, yeah. So that's the power of blockchain. There is that bit of authenticity due to the immutability, yeah. So blockchain has various use cases, very, very many use cases, yeah. And it has use cases in decentralized finance. It has use cases in insurance. The most used case in Africa currently is finance, because we have issues with sending and receiving money, yeah. So just imagine a case, if at all someone in America has to send me $1,000,000 shillings. Maybe you have an uncle, and this uncle of yours is in America, and you are receiving $1,000,000 shillings, yeah. This $1,000,000 shillings, the costs, the charges related to $1,000,000 shillings are very, very, very high. You may end up being charged something like 20, 30,000, yeah. It can go as far as between 10% to 20%, yeah. So, but if at all someone is sending this money and it's in form of crypto, yeah, if at all they are sending it from their crypto wallet, yeah, to your crypto wallet, it will take first, you're receiving the other 1,000,000 by fiat. Fiat means local currency. Fiat means UGX. It means USD, yeah. So if at all you are receiving money, it may actually take 24 hours, or it can even take more than 24 hours. But with crypto, actually even in less than 3 minutes, you would have received that money, yeah. So now just imagine, and the transaction charges are very, very, very low, yeah. It's like 10% less transactional charges, yeah. So what better system is that? So, and this is where this is where technology is heading. Yeah. So right now, what is affecting the world? One of the trends in the world is blockchain. Yeah, and that's why we need to take it serious, because very many innovations are going to be built on top of the blockchain. So our bootcamp is a build on Starknet bootcamp. This bootcamp is we are going to build on Starknet, and Starknet happens to be a blockchain which is built on top of Ethereum. Yeah. So about the bootcamp, so the bootcamp is an initiative by the Starknet Foundation, and so this is a 4-week course. It's not a so the first session we had was general introduction to blockchain. The second session was introduction to Starknet, which is this second session. Then the third session will be building on Starknet, and then fourth session will be advanced Starknet smart contract development, and then testing smart contracts, and then we shall see how do we build a front end and use a blockchain in the back end. At the end of this bootcamp, we are going to have international certificates. Yeah, me personally as well, to become a teacher, I first went under a boot camp, and after you go in a boot camp, you are given a certificate which is international. So by international means that this company, Starknet, is an international company, so you can use this certificate as a proof to show that you have learned, you are aware of what Starknet does, and even you can use it to in case you are looking for a job opportunity. Right now there are various opportunities. Blockchain, you hardly find a blockchain developer. Yeah, so the job market is actually there for blockchain developers. Yeah, I personally work on some remote projects in blockchain. Yeah, and I'm not very so old in this game. Yeah, one thing with technology is that it's about the ability that you put in. Yeah, if at all you put in the zeal, if at all you put in your energy to look for skills. Yeah, I was a developer before. I was a developer in Web 2, but I wasn't a blockchain developer. But I just transitioned from being a Web 2 developer. So our first session was being done by a one Vian. Vian is also a blockchain developer. And then the next sessions are going to be conducted by. So there is a graduation requirement. Yeah, nothing comes on a silver platter, so we have to put in some effort. So for every attendance that does, I'm yet to share the attendance link here. So for every attendance that happens, there are marks which are awarded to that. And then as well, at every session we shall be sharing some tests, very easy test questions basing on what we have covered in the session. And these are what are going to compound to generate a point system, the points you're being awarded in the course. So there is, I liked it when I saw Keith. He really looked out for node guardians. I was really so pleased. Node guardians as well helps you to understand Starknet and blockchain. So in case you have any questions, let me share the link to node guardians in the let me just share the link, just a minute. Node guardians. Just a minute. It's actually, in case we are good, you can just give me a thumbs up. Thank you so much. So you may be asking me, so Starknet, I said, is a chain which is built on top of Ethereum. So the internet is the layer 0. I want us to understand, I'm going to explain blockchain and everything to do with blockchain in terms of layers. I want us to just imagine an onion. An onion has the outer layer, it has various layers, not until you reach what is called the bulb in the middle. Yeah, the bulb is the white fleshy thing, which is a bit solid. That's a bulb. So I also want us to understand the blockchain as that. We have the outer layer, probably the outer layer is, let me call it a layer 0. Yeah? So the layer 0 in this case is the internet. Everything we are building on top, we are building it on top of the internet. And then we have a layer 1. Yeah, because the current internet is centralized. Yeah, but then we brought the guy who built Ethereum. Yeah, so Ethereum has its weaknesses, and Ethereum basically was built to handle things like security, yeah, settlement, yeah, and then scalability. Yeah, but then there are things it's not doing well. It's doing well so after every cycle, maybe after every how can I call it, just imagine after a certain period, the builders of or the people who maintain Ethereum, they have to sit down and assess how far they have come. Yeah, what are they doing right? What are they not doing right? Yeah, and they found out some of the weaknesses. Yeah, so in that, one of the weaknesses of Ethereum as a layer in the blockchain is its scalability, performance. Yeah, so by nature, because the blockchain, they are interconnected blocks. Yeah, because it's a decentralized system, that means information like this, the blockchain is slow. Yeah, because I said one node has to talk to the other, like that. Whatever happens in one node is being shared into another node. Yeah, so that causes a lot of performance issues in the blockchain. Yeah, but then, as I said, Ethereum is a layer 1. Now there are certain things which have come to solve the problem of performance. Yeah. Now what comes in that is that we look at things, those are called L2s. That's another layer. Ethereum is the best layer, it's the layer 1. And then we have things which are solved. We have layers, yeah, chains which are built on top of Ethereum, yeah, which are solving things like performance, yeah. So Starknet as an L2 is trying to solve the problem of performance in Ethereum. Yeah? And how it attempts to solve this is that Starknet has its own programming language. Yeah? And then this programming language is Cairo. Yeah? So how many of us have heard of I know we've heard of virtual machines. Yeah, so in a virtual machine I can have a virtual computer on my physical computer. Yeah, so Starknet attempts to solve the performance issue in Ethereum. So one of the session topics we have is why Cairo. So we are going to look at the Cairo programming language, and then why Starknet as the chain. Then we're also going to look at smart wallets, and then we may have some test questions. So I said our bootcamp is powered by Starknet. Starknet is the chain specifically which we are looking at. So you may ask yourself, why do we need to cover Cairo? Why do we need Cairo? Why do we need it? Cairo is the programming language behind Starknet. Ethereum as a layer 1, it's built, it uses Solidity programming language. Yeah. So I just want to explain this in one thing here. So just imagine, yeah, you want to launch something. Yeah, I want to use this paradigm properly. So when maybe I want to launch something, maybe if at all I'm having a vehicle, yeah, and if I'm attempting to buy a vehicle, I look at things. So if at all, yeah, I'm having this vehicle, maybe I'm told Benz has a lot of, maybe Benz, the spare parts are so expensive. If at all I have a Benz, yeah, but every time it gets spoiled, maybe in a year it gets spoiled like thrice in a year, but every time it gets spoiled, I need to go to Dubai and get spares, yeah, spares for this Benz. That means it's like I bought a car, but it's not helping me, yeah, because every time my car gets spoiled, yeah, I have to ship spare parts, which is expensive, yeah. But then to solve that problem, that means when I don't have a car, I have to borrow either my friend's car or someone's car. But then this person can refuse to give you this car, yeah. This person can refuse to give this car. So in the whole process, traditional languages like C++, traditional languages like C, when they run code through a compiler and then you get a result, yeah, there is nothing like that verifies the result which I've obtained, yeah. But just imagine, and there is something that there is a lot of power in verification, yeah. For example, if at all I was running some program, yeah, and if at all this program has run, I have to verify that this is the exact thing which has run. So when this thing runs, at least I'm sure, well, this program has run, but this is the intent of why it was supposed to run. I'm not only bothered about the solution, but I'm supposed as well to be bothered about the verification, the results that I've obtained. Yeah? So that's what Cairo does behind the scenes. Yeah? So with Cairo, when I run something, when I run a program, when I run a program, maybe a software, yeah? Okay, I want to break it down in terms of a program. A program can be a module, or just imagine you have run a file from your computer, yeah, and then you have after running the result. When I get a result, it gives me a proof that actually the results that I've obtained were the actual results that were supposed to be generated. Yeah, so that's what Cairo does in the blockchain, in the Starknet blockchain. So when you get data, you have to feed it somewhere, and then you have to feed it in something called like a model, yeah. But it's not a master that is supposed to own that model, yeah. So the model is supposed to either generate, maybe you had a hypothesis that maybe all students in Chambogo University, yeah, got first class. Yeah, so how to feed it with data? Maybe I'll feed it with data with software engineering students, I'll feed it data with computer engineering students, I'll feed it with data of IT students. Yeah, so but then what happens? For my answer to be correct, yeah, I have to ensure that all the data that I've fed it has been tested. Yeah, but then a case can come in whether not all this data has been tested. Yeah, because there is no verification. So the people who built the Cairo programming language, they had verification at the back of their mind. Yeah, that when this thing happens, there must be a verification proof that has to be generated that this is what has run and this was the expected outcome. So the Cairo programming language is built with verification at the back of it. It enables verifiable computations. Yeah, so Cairo programming language is inspired by Rust. There are very many things in Cairo which are similar to Rust. Yeah, and we may have a small session to look into the Rust programming language, because if at all they share very many similarities, yeah, then it would be beneficial for us to understand how Rust works. So there are various data types in the Cairo programming language, and then well, a runtime. What is the difference between a virtual machine and a runtime? Yeah. So to give an example of a runtime, there is a perfect example of a runtime can be, yeah, when you are installing Node. I want us to best understand a runtime. So most of us, if at all you've been in the technology space for some time, we know what VMware is. VMware is it's like a workstation. For example, if at all I have a computer, yeah, but then in a computer I don't want to install another operating system. Yeah, I can just invoke VMware. VMware powers a virtual machine. Yeah, and then in that virtual machine, I can then install the operating system that I want to be on the virtual machine. I can decide to have their Windows, but then maybe right now, like for me, I use Linux. But in my virtual machine, I may decide that no, I want to have a virtual computer, yeah, and then on the virtual computer I have. But if I told my computer maybe has 4 GB, if I told my computer has 4 GB of RAM, it may be difficult for me to have a virtual machine which has 32 GB of RAM. Yeah. So I want us to understand a VM, a virtual machine, as a virtual computer. Yeah. And then a runtime. I don't know how I can best explain it, but a runtime is just. So hopefully, Stephen, I've answered your question. Let me read from your explanation. My interpretation is that a virtual machine is a software framework that utilizes the resources of its parent device, but a virtual machine is actually a computer. Yeah, it can be a software framework that utilizes the resources of its parent device, but here's just like an actual machine. Yeah, you're very right, Stephen. That's what it is. So the Cairo virtual machine is built on top of Ethereum, yeah, but it's built on top of Ethereum, but it does not fully utilize the Ethereum virtual machine, yeah, because the Ethereum virtual machine has issues with performance. Yeah, as I was starting, I explained three things which Ethereum was designed with the builders of Ethereum. They looked at three things, and one of them was security, settlement, and scalability, which is performance. Yeah, so because of that, Ethereum has not handled. So it has right now Ethereum, as the L1 as a base layer, it has decided to focus entirely on the security bit of it. Yeah. So now the L2s, yeah, which are now built on top of Ethereum, yeah, are the ones which are solving the weaknesses of Ethereum. And one of the L2s is Starknet. And what Starknet brings to the table is to scale Ethereum, yeah, is to improve Ethereum's performance, yeah. So let me continue. So, okay, I see another question. Return verification. Some more light on the part of having to use Cairo in projects that require verification. Yeah. So Cairo is a programming language, yeah, which fuels the Cairo virtual machine. It runs in the Cairo virtual machine, and the Cairo virtual machine, yeah, is separate from the Ethereum. For example, Bitcoin is a proof of work, yeah, and then the Ethereum is proof of stake. Yeah, that's how that's the consensus mechanism that are being used. Bitcoin is proof of work. That's why in Bitcoin you have to have miners. Yeah, so miners are the ones who are verifying every transaction which is happening on the blockchain. Yeah, and every miner has to have those heavy machines which need a lot of internet, which consume a lot of power. Yeah, but it's so expensive to validate that an activity has taken place on the in the Bitcoin, because you need a lot of energy. You need those heavy duty machines, yeah, which are acting as validators. That's why the machines have to be on. That's a condition. And besides the machine being on, you have to have reliable internet, very quick internet. But that's very expensive. Not everyone can set up a mining center. Yeah. So now, for Ethereum, the thing is a post request. Yeah. So in our Web2 applications, yeah, if I've written a message and I'm sending it to someone, that means I've a post request. Yeah. So that post request in a blockchain is known as a transaction. Yeah. And it's expensive because it's something added. Yeah. Now, if I told you from the Web2 space, I want us to, there is a GET request and then there is a POST request. So in a POST request, you are adding something to the database. In a GET request, you're just retrieving, yeah? So a GET request is usually faster, yeah? That's why when you're on your WhatsApp, messages are first downloaded before you send a message, yeah? So it's the GET request first, then a POST request. So a post request means a decentralized application, and it's on Starknet, yeah? So this decentralized application, maybe I'm sending money, set up maybe to send money, someone is in Ghana, yeah? If at all I'm just receiving money, yeah, that's a GET request, yeah? So it's not consuming resources on the blockchain. But if at all I'm sending money to this person, yeah, there is work behind the scenes that has to be done, and part of that work is very validating, yeah, that what I've written is not breaching anything on the blockchain. Now, the people who are there to validate that, for you to be a validator, you must have, those are the guys who are having nodes. So for my decentralized application to go live on the blockchain, I must host it on something. So everything on the blockchain, yeah, you must need a node. So because you as a person, you don't have a heavy duty machine to act as a node. So there are nodes which are already in existence, but you have to just pay them, you just pay some fees, and then part of these fees are going to the node operators, and then there are people also who are validating these blocks. So as I explained, everything that is being added on the blockchain has to be validated, because we have to ensure that the blockchain is secure. Yeah. So after everything has been validated, yeah. So just imagine that I've sent 1 million shillings to my friend in Ghana, and I have to ensure that this person, so in blockchain there is, and I call it an analogy known as the zero knowledge proof. Now, how zero knowledge proof works is that the zero knowledge proof is categorized into what we call the validity, yeah, and optimistic rollups, yeah. Now, how the optimistic rollups work is that optimistic rollups have to go through block by block to verify that actually, yeah, the blocks, maybe the blocks to make 1 million shillings, yeah, maybe I'm supposed to send 1 million shillings to Keith. I have to ensure their blocks, maybe they're supposed to be maybe the block state has to be maybe the block state for 1 million shillings, if at all it's supposed to be 50. In optimistic rollups, the nodes have to execute 50 blocks to ensure that, well, this is right, yeah. But for validity rollups, they don't need to execute a lot of this work. All they need to do is, when money is being sent to a person, maybe 1 million shillings, yeah, they generate a computational proof, yeah, that this is what has happened, and this is the proof they share, yeah. So in that I don't need to go. Keith, are you now clear? Thank you so much.
Yes, you are,
Small
question.
Yeah,
Eh,
yeah.
what is so
What is so
special with
special with
Cairo?
Cairo? Like,
It's been
it's
playing that
been
part
playing
of
that part of
verifying the
verifying the
zero
zero
proofs and
proofs and
validity and
validity and
optimistically.
optimistically.
Okay. Yes, is the language that powers the Ethereum blockchain is called Solidity. Yeah. But as I said, yeah, Solidity, if at all Starknet was to use Solidity, that means, well, yes, Marie, I'm going to explain the node operator, but let me first get this out of the way. So, if at all Starknet, yeah, was entirely an EVM, that means it was supposed to use Solidity. But as I was starting, I said Ethereum has its weaknesses, yeah, and then for us to have a smooth flow, or for us to have various innovations in the blockchain, we have to ensure that these weaknesses are solved, yeah. And one of these weaknesses is performance scalability, yeah. So as I've explained, yeah, so if at all Starknet was to solve the issue of performance, that means it was not supposed to be built entirely as an EVM. Yeah? Yeah? It's not supposed to rely entirely on the Ethereum virtual machine, because we have seen the Ethereum virtual machine has issues with performance. So that's why the Starknet has its own. If at all you are from a Web 2 background, yeah, your web application, you have to use a hosting person. Maybe if at all you've written a React application or a Next.js application, you have to host my application. Yeah? You don't have the required CPUs. You only have, yeah, you don't have, these things are happening, but remember, everything has to be put on the internet. Yeah? But for you just have a physical machine. So you have to look for an entity which has enough capacity to run your application. For example, if at all I've programmed my web application to send, maybe after every second, to be sending like 10 SMSs, yeah, that is a supercomputer, yeah, internet, like in the internet as the network, yeah. So that means I have to host my computer, a cloud, with the people who are doing the hosting, so that they can get my computer up and running. So that's the same case with the blockchain. If at all I've written my application, a decentralized application, maybe it's sending money somewhere, yeah, but all these nodes, for me to have a node, it's expensive to me, but I don't need to have a node. Yeah, I can just pay some fees. Yeah, I can just pay some fees to the person who's running my decentralized application. Yeah, and that's what is called a node. Yeah, so for me to have my decentralized application, I must, for it to go live on the blockchain, I must get it through a node. And now these nodes are the ones which are maintaining the blockchain. Yeah, and then there are certain fees which go to these node operators. Yeah, and those are the ones, people who are validating. Yeah, as I said, for every decentralized application, there is a term called gas fees. Now, gas fees, part of the gas fees is that before every block is added on the blockchain, yeah, there is a gas fees which is sent to the validators. So I want to look at, I'm just going to have a structure layout of the Cairo programming language, how it looks like. Yeah, so the Cairo programming language, we are going to have a practical session. It may either be at the end or it may be the next session. So in the Cairo programming language, we have data types, yeah, and we have data structures. If at all you are from if at all you are not new to programming, you must have heard of things like in Python, names of students of this data. Maybe it's students, yeah, students in a classroom, yeah, and then these students, I have to capture their names, I have to capture their age, I have to capture their telephone numbers. So I have to look for ways of categorizing this data. So that's the same thing even in Cairo, yeah. So we categorize data in things, yeah. This is just a struct. So in my struct, I'm explaining a rectangle, yeah. A rectangle can have a height, it can have a width, yeah. And as I said, the Cairo programming language is inspired by the Rust programming language, and though the Cairo, if I declare something, yeah, I have to give its type, yeah. When I describe a rectangle, and a rectangle has a height and a rectangle has a width, I have to tell you that the height of the rectangle it cannot be a string, it has to be a figure, yeah. So that's why we shall look at various things, yeah. So I'm just giving just a simple layout of how the Cairo programming language looks like, but we are going to have a practical session of the Cairo programming language in detail, yeah. So we are going to look at things like traits. We are going to look at things like a trait is similar to an interface. If at all you have written TypeScript code before, a trait is similar to that. But you shouldn't be scared about this. We are going to have a practical session of the Cairo. So it may either be at the end of this session or it may be in the next session. So just this is to show you how the general structure of the Cairo programming language. So then this is a summary. We are going to, so we have talked about Cairo. It enables verifiable computation. Yeah, there's a proof of computation integrity because it's verified. Every transaction is verified. That means there is integrity. And why Starknet? Yeah. Why Starknet? Why Starknet as an L2? Why is this bootcamp focused entirely on Starknet? Why? So I talked about the scaling problem of Ethereum. Yeah, Ethereum as a layer 1, it has some issues. It has something is not handling properly, and one of those things is the performance. Yeah, so that's what Starknet specifically comes in play to solve. Yeah, so I said everything that happens on the blockchain, yeah, I want us to understand the blockchain as this. If at all, before anything is happened, we have a state, maybe a zero state. But as something happens, yeah, our new state, for example, if at all I'm having a decentralized application and I'm sending money to Joshua, yeah, before I send money is at zero state. Zero state means nothing has happened, no block has taken place, everything is as it was before. Now, when I send money, there is an activity which is taking place. That means there is a new state which have a new state because an activity has taken place. Probably. Okay, Steven. Please elaborate clearly what is the actual Ethereum performance issue that Starknet addressing. Is it transactional finality speed or something else? Thank you so much, Steven. So Starknet is solving. I was introducing Ethereum. Ethereum was as they were designing the Ethereum blockchain as the base infrastructure. They had three things in mind, and one of these things we have security, yeah, security which is privacy. We have scalability, which is performance, yeah, and then the third we have its security, settlement, and then scalability, which is performance, yeah. But it was realized, yeah, that Ethereum had failed to do all these things intermittently, to do all these things very well at the same time, yeah. So then the people who maintain the Ethereum blockchain, yeah, they decided to focus entirely on the security, on Ethereum being as a security layer, yeah. So now the other things which came in play, so the L2s, yeah, which are built on top of Ethereum, they are trying to solve the weaknesses of the Ethereum as a base layer. And what Starknet, as explaining, when anything happens in the blockchain, after every activity, there is a new state which is being generated. For validity rollups, yeah, as I said, Starknet, at the end of every transaction, there is a computational proof, yeah, which is being generated, yeah, that this is the proof that this thing has taken place. You don't need to run to check all these blocks. Yeah, you don't need to do work for block, yeah, to verify that this is the state, to verify that this is the new state in the blockchain, yeah, because that consumes a lot of energy, yeah, yeah, and it's adding on the slow nature of the blockchain, yeah. But this is what Starknet, this is what Cairo, Starknet through Cairo does, yeah. So instead of, if at all an activity has taken place, a new block has been added on the blockchain, and the new state, as I said, before any transaction takes place, yeah, there is an old state, yeah, the state is zero. So after transactions have taken place, maybe you've sent people money, blocks are added onto the blockchain after they have been verified, yeah, and then there is a new state, yeah. So maybe 10 blocks are, so this is for verification. This is just a graph, yeah, to just illustrate something of performance. So I want us to understand something clearly here is that valid, like Starknet, yeah, are to handle a thing of computation, yeah. So validity proof, all they're handling is how many transactions. That means Starknet, because it does not need to do work, it does not need to verify, to do work for block by block, it just needs to verify it. That means I can have various, the time spent on 1,000 blocks, yeah, maybe I've sent money and 1,000 blocks have been verified, have been added to the blockchain, yeah. and a verification is being generated, a computational proof. It's the same work which is being done from one block when it's added. Yeah. So, you know what zipping the file does? Yeah. For example, if I told, so in case you have any question, please feel free to raise it. So validity proof, a use case of zero knowledge proofs convinces verify on L1. L1 is Ethereum of new L2 states, yeah, without sharing transactions details, yeah. So Starknet does not need, yeah, I don't need to show details for other chains, which other L2s which are non-validity proofs. They need to return details of every block which is being added. But for Starknet, only needs to give me a proof, yeah, that this has happened, and this is the proof that this has happened. So Starknet validity proofs make verification efficient. So Starknet is based on stacks and non-SNARKs. So there are various technologies for Zeke. So here there is a of the stacks and versus the SNARKs. Yeah. So in terms of the proving time in the chains which use the stack technologies, yeah, the another chain which uses stacks is the Polygon. It borrows the stacks technology. So the proving time, the time needed to prove the transactions in Starknet is 10 times the time needed. So as I said, Cairo VM is independent of the Ethereum VM. So with that being independent, because Ethereum has issues with performance, Cairo VM is better than other. The Zeke EVMs here, what they're meaning is zero knowledge proof Ethereum VMs. These are EVMs which don't have an independent programming language, but they're running entirely on the Ethereum virtual machine. So they have performance issue in comparison to Starknet. So I talked about this, about compatibility and performance. I don't want to go into details of it. So Ethereum was designed to handle things like security, settlement. Settlement means that everything which is happening on top of Ethereum, maybe as Starknet is an L2, because Starknet is an L2, it's operating on Ethereum as a base layer. Yeah? And everything that happens on Starknet has to be settled on Ethereum. Yeah? But because Starknet is a validity roller, because it doesn't need to return details of every transaction on the blockchain, yeah, it takes only 2 hours, yeah, to settle. For example, because I said there are gas fees which are paid to the validators, yeah, so there is some gas fees which goes to Starknet, and then there is also some gas fees that Starknet gives to Ethereum, because it's the base layer, because it's providing the infrastructure. So the time it takes to settle everything, all these assets can be Ethereum virtual machine is 2 hours, while for optimistic rollups, because they have to verify every block which is being added, they have to return the details. That's a lot of work. So they take 1 week's time to settle, yeah, all these details on the Ethereum virtual machine. So that's why the transactions, just imagine you have in a game, because games are really quick things, so you need to you're having, and maybe for every character for every character which is, maybe there are various users who are adding characters, yeah, into this game, but this game is built on unoptimistic rollups. As I said, in an optimistic rollup, yeah, everything is every block which is being added, the slides have showed us that it takes close to a week to settle it on Ethereum. Yeah, but just imagine there are various players who are adding a character to this game, and this game is built on an optimistic rollup, which is not Starknet. That means the transactions which are happening. So why Starknet? Starknet is optimized for Zeketech, the computing power. It has a high computing power, and because the transaction per second, because it handles a lot of transactions per second, yeah, and we don't need to reveal details per transaction. That means it's consuming gas fees. Every transaction which is happening on the blockchain, it takes gas fees. Every transaction which is happening on the blockchain, it consumes. So I want us to look at something here, smart. So we've been talking about gas fees, and you may ask me a question: how do we pay these gas fees? Yeah. So now that's how tokens come into play. Yeah. So every chain has to have a token it uses where Dapps, where the token is to aid to pay for the gas fees, yeah, on the blockchain. So that's the token for Starknet, and then currently, let me show us one stack to USDT. The USDT is the equivalent of the tether dollar. So one stack is equal to 0.68 USDT. So we use the stacks. So the stacks they are traded on blockchain on USDT, and yeah, it's a medium of exchange. Yeah. So because I can convert it to USDT, and we take the USDT. The USDT is the Tether USD, but then there is what is called the USDC. So you can, if at all you have stacks, we have seen one stack is 0.68 USDC. You can convert it to USDT, and then USDT you can trade and convert it to Ugandan shilling. So, but we want to look at what smart wallets are. So a smart wallet, let me open a smart wallet right here. A smart wallet I have, so let me just introduce it and I show us a live thing. So it's for us to interact with the blockchain. Maybe I've made my decentralized application, yeah, but I need maybe people to be sending me money in this decentralized for the wallet address. Yeah, so your wallet address is an equivalent to your account number. Yeah, in Starknet. So on Starknet, every wallet address is a smart wallet. Yeah, and then we have providers of this wallet address. We have agent and bravos. So in case you want to create a wallet address, you can just go. So wallet addresses, we have agent. Smart wallets, we have agent and bravos. So you just go. Hope my screen is clear. So you just go to bravos. Then they will give you instructions on how to rolling. So in case you have data, you can follow along. Then they will tell you to so there is here support for Chrome. So I've clicked on Chrome. In case you have the internet with you, you can follow along. So I've clicked on Chrome here. So in Chrome, you just need to install the extension. So you can just go here, browse.app. So there is a wallet extension here. So in case you need to create a wallet address, when you click on, if you haven't yet installed it here, it will tell you add to Chrome, and then it will add as an extension. So it on your toolbar, you just come here, extensions. So let me, since I already have mine, let me just open it here to show us how it looks like. So that's how a wallet, the Bravos wallet looks like. Yeah, so as I said, after adding it as an extension, in case you need to pin it to the toolbar, you just come here to manage extensions. And in manage extensions, it will bring you some anything not clear, in case you need some clarification on that. But that's Bravos. And so in case I need to send my wallet address, maybe someone wants to send me some money. Let me open my wallet extension here. All I just need to do is come here and then copy that address, and then just come here and paste it. So in case you want to send me some money, you can bless me with some money there. That becomes like an equivalent of my account number. That's like an account number. So if you want to bless me with some money, you just do it there. And then in case you need to send money from within Starknet itself, from within Bravos itself, you need to ask for your address, the address similar to what I shared. You paste it there and then you put the amount. So when I put the amount, if at all I want to send more than I have, it will tell me I have an insufficient balance. So you have to send, just like in a bank, you have to. So that's what a smart wallet is all about. So guys, I have an exercise for us. I want a browser extension, yeah, and then when browser extension, I want you to create an account on mainnet. So you can have an account on testnet and you can have an account on mainnet. So testnet means just for trial purposes, because to experiment with anything on the blockchain, yeah, you need to have money, and this money can be test money, or it can be real money. So in case you are building and you haven't yet deployed your app in production, you can, so I have the test, you can have a test just like that's my test name, Starknet Sepolia. So it's telling me switch to this testnet. So now that's my testnet, yeah. So in the testnet I have some $92.32. Let me download it and share it. Let me share the slides straight away, of course. But meanwhile, we are soon approaching the end. Let me share the slides. So guys, that's the link to the slides. You can get the slides from there. But I'm also going to share the hard copy in. Yes, Lyndon. You're welcome, Lyndon. You can.
Yeah, I'm glad to join here, right here. It's good work.
Yeah, thank you so much.
I'm just getting the computer ready. I just had a couple of projects I was trying to finish up. So,
It's very fine. It's very fine. It's very fine. You can just follow along. We have the previous session on YouTube. Yeah, so guys, I've shared the link you can use to access the. So install the extension, create an account, and then find wallet with faucets. That can be a good homework. I don't want to. So I'm going to share the registration link. Are you meaning the link for attendance or for registration? Please be clear. Attendance.
The link for exercise and participate.
Yeah, let me share
I don't know if it can come on my WhatsApp. It's much more better. Like
You're welcome, Vian. Let me share the link for attendance right. So I left an exercise, install Bravos, create an account on mainnet, and immediately after the session, I'm going to share this. So whoever is not on our Telegram group, I request Mr. Vian to share the the link to our Starknet Kampala Telegram group. Vian, yeah, I request you to share. I'm going to share the notes in the Telegram group, but I request you share the link to our Telegram group. So I'm going to share the physical notes right there. So I just want us to show us how to find our, it can as well be even a good exercise for us. Yeah, so these are the bits of the slides are talking about account abstraction. So in Starknet, we have a hardware device. For example, in this case, my hardware device, it's a computer, it's a laptop. Yeah. So the hardware device is a signer. So the hardware device as a signer, it harbors the smart wallet. Yeah. And the smart wallet, we have seen that it's either Bravos, yeah, it's the one Bravos wallet extension or Agent X. So it's the one which is harboring, it's the one which is helping you to create a smart wallet address. Yeah. So a signer, yeah, is the device, yeah. And then we have a smart wallet, yeah. And then from the smart wallet is where we have an account which we use to deploy on Starknet. So a signer is so another exercise right there. You can interact with the smart contract, check transaction details. So this one I will make sure that in our next session we have to go through it together. Yeah, so signature verification. Yeah. So a signer, as I said, is a hardware device. Yeah. It releases a signature. Yeah. That needs to the signer releases a signature which can be picked. I can detect that this transaction maybe is coming from a smart wallet. So just a summary of what a smart wallet is, better UX. Smart wallet is to create a smart wallet. We've seen you need things like agent, Bravos, and then enabled by account abstraction. That the signer is that signature, yeah, from the device to the smart wallet, then from the to the smart contract, yeah, on Starknet. So exercise 3 is kind of similar to exercise 1. You may install Bravos, or you may just create a wallet extension, Of course, you have to back up your seed phrase. Your seed phrase is very important because when you lose it, you're actually losing your money. So Starknet at the moment, Starknet is the cheapest L2. Yeah, it's 10 times. Yeah, in case guys you have any meetings, you may in case you have any questions, you can just raise them up here. I thank you Kakoza for sharing. But in case you have any questions, you may raise them there. But besides that, I thank you so much for being part of our second session. Our following session is going to be so practical. We're going to dive deep into the Cairo programming language. So thank you so much, guys.